Hi folks, we're going to take a look at questions 1D and E from the Unit 6 assignment part 2. Okay, so this, as you probably guessed, this should be h at x. So there's h at x, very odd thing about this printer. Okay, so I want to determine the domain of j of h at x. So the first thing I'm going to do is let me actually write out what this function is. Okay, so j of h of x, okay, would be equal to, okay, well, j of h at x is equal to root x, okay, and j is equal to 2 to the x, so I have 2 to the root x, okay. So this is the function that I'm trying to find the domain of. Okay, now how does the domain of a composite function work? So x needs to be in the domain of my first function, so needs to be in the domain of root x, and those outputs need to be in the domain of my second function, 2 to the x. Now let's actually deal with the second function. 2 to the x has a domain of all real numbers, so it will accept any input you give it. The only restriction here is what outputs are going to come out of here. Okay, and so here we see that root x, so h of x, okay, has a domain. Okay, so if I give the domain of all real numbers greater than or equal to 0, so from 0 to positive infinity. Okay, now the outputs, I mean in the end, if you think about what the outputs are, all the numbers again greater than or equal to 0, but it doesn't really matter because 2 to the x will accept any value you give it. So in the end, the domain of j of h of x ends up just being all numbers from 0 to positive infinity, including 0. Okay? But again, the way in which you do this is first you have to determine what x values are accepted by the first function, and then make sure that you take only those whose outputs are accepted by the second function. In this case here, we didn't have to worry about that because the second function had a domain of all real numbers. Okay, let's now find I circle f at x. Okay, so remember I circle f at x is the same as I evaluated at f at x. Okay, so I at x cubed minus x, and the function I at x is log base 2. So we're left with log base 2 of x cubed minus x. Okay, so again we go through the same process. The domain is all values in the domain of f, which is all real numbers. Okay, so no restrictions coming from the first function. Then those outputs need to be in the domain of log base 2 of x, and of course log base 2 of x, okay, has a domain of 0, not inclusive, to infinity. So essentially what I need is I need x cubed minus x to be strictly greater than 0. That's the condition I have to satisfy. Okay, but here I've got a polynomial inequality. How do we solve a polynomial inequality? Well, it's all about finding the zeros of this polynomial, because those are the only places where this function can change signs. So I do that by factoring. So x times x squared minus 1. Okay, and of course, x squared minus 1 is a nice easy difference of squares. Okay, and so now I know that the only places where this can change sign is at -1, at 0, and at 1. And since this is a cubic with a positive leading coefficient, I can quickly draw this graph, okay, and see that my domain, okay, is just given by all values between -1 and 0. Okay, and then I'm also going to take all values that are greater than 1. Okay, and notice how I'm not including the endpoints because I can't have this function equaling 0. Okay, that's it for these.